In this lecture we're going to introduce how to interface your PIC16F887 with the LCD display in the QL200 trainer kit. LCD displays are used in quite a lot of devices. They're a great way to give some simple feedback. They allow us to display characters that we wouldn't be able to display on 7-segment displays, so we can have text, we can have some special characters, really anything you can make out of just a small pixel grid can be displayed on LCD panels. And so you see them a lot. Vending machines that indicate how much change you're going to get back, or how much a product costs, or just scrolling a message, enjoy an ice cold Coca-Cola, or whatever it happens to be. Gas pumps often use these to display messages, and so on and so forth. So there are a few different things that you can do to control an LCD. And so there are commands that the LCD panel will use, and there's also data that you can send to the LCD panel. And along with this video lecture on the Blackboard site, if you're enrolled in this course, you will be able to see the data sheet for the LCD panel that is included in your trainer kit. So you can get some more information about what the commands are that can be issued and what data you can send into the LCD panel. And the interesting thing, LCDs in general accept either serial commands or parallel commands. So it really just depends upon what type of LCD panel you're using. In this case, we have one that accepts information in parallel. And some instructions can do several different things. You can turn on or off the backlighting of the display. You can configure whether information is going to scroll versus staying on the screen. You can clear out the text or any other characters that are on the panel. And you can also move the cursor position across the screen so your text can appear in different places. So here is the pin diagram for the LCD that we have. It is a 16-pin device, and you have to supply power and ground to it, as you might expect. There is also a contrast adjustment, which on the trainer kit we will just usually leave all the way to maximum contrast. And then 3 special pins you will definitely need to make note of are RS, RW, and E. And the RS pin distinguishes between whether you are sending information that is an instruction, so things like clearing out the text or moving where your cursor is, or just how you're going to configure the display, or data. And the data would be what character you want displayed and where you want that to be displayed. RW is to determine whether you are writing to a register or reading from a register. And then the enable signal really acts as a clock for the data and the instructions. And so if you set up the appropriate data or instructions, and then you toggle the enable signal, and so generally we'll set it low, wait, and set it high, and wait, just to get a nice rising edge on there. You can clock in the data. And then pins 7 through 14 are connected to port D in the trainer kit, and that is where 8-bit data or 8-bit instructions are written to the LCD panel. And then you also have some supply voltage for the built-in backlight. So pins 15 and 16 are the positive and negative for the light that is behind the LCD panel. So, as we mentioned, RS used to distinguish whether you're talking about sending instructions or you're sending data. RW distinguishes whether you're reading or writing, reading from what is already on the LCD panel or writing to it. In most everything we will do, we will be writing to the panel. And then your enable pin acts as a clock, and DB0 through DB7 are where the data is written to the LCD. So here you see some more about the pin diagram. This is in the QL200. and so you can see where these pins are connected. And so you happen to have these different pins on there, and this shows on your microcontroller which pins of the microcontroller are connected to the different ports that you have here. In general, your instructions are going to be coming from port D, and then RS, RW, and E are going to be coming from port A. So here's what you have. RS is port A pin 1, RW port A pin 2, and your E is port A pin 3. And as we already mentioned, port D is where you're going to write out the instructions. And then all of the voltages in terms of the contrast voltage and the power for the light coming in there are hardwired. There is a potentiometer on your board, but you won't need to adjust that for the contrast. So here you can note the instructions. There are several different things that you can do, and so in this case we're talking about instructions. So your RS is going to be 0. You're going to be writing these instructions, so your RW is going to be 0. And then here are the values that get written. So if you write out zeros with a single 1 over there, so hexadecimal 0, 1, that clears the display. Really what it does is it writes the character 20H in hexadecimal, which is actually ASCII for a space, to all of the memory locations corresponding to the data to be displayed. And so you're just overwriting whatever text or other characters, numbers happen to be on the display with a space. The return home is indicated here. Again, it's an instruction, so RS is 0. You're going to write it, so that's going to be a 0 there. And then if we look, that's going to be 0. And then in the lower nibble, we have a 1 here, and then this is a don't care. So you can put either 3 or 2, and that will return you to the home position. And the home position is considered memory location 0 in the LCD panel. So there's memory locations starting at 0, and then they increment across to the maximum number that you can have across one line, and you can also put it into 2-line mode. Then the next instruction allows you to change the mode of entry, and so this does several things. This really determines which direction the cursor will move as you have different commands or different data going across. And so this allows you to have international support. So in some languages the characters are read left to right, such as English, and in other languages characters are read from the right to the left. And so this allows you to move the cursor one direction or the other, depending upon what you want to do. Then, to turn the display on or off, you can use this next command you see here. Again, RS is 0, that's an instruction. We're going to write this, and then again the upper nibble is a 0, and then you have 1 with a D, C, and B right here. So D determines whether the entire display is on, and so you generally want that to be a 1. And then if your cursor is on, you can put a 1 right there, and then if the cursor position is on, you can put that there too. So you have the option of having a cursor, and that cursor can scroll across as you have text, or you might just want the cursor to be hidden in the background, so you can do that here. And then you have the cursor or display shift, and so here you can put in some different values, and that sets whether the cursor is moving and some of the display information there. Then over here you can set some specific functions. So this will determine how your interface is configured and whether you're using a 2-line display or just 1 line. You do have that option. And then this will also determine the font size. And you'll see in some sample code what values we like to use for that. And then you can determine the RAM addresses. And so the RAM addresses are where you are going to store the data going through. And then here you can check some flags that determine whether things are busy. And then down here, this is where you write data or read data back. And so in that case, you put the values that you want to send, generally ASCII values, into the LCD so that you can display that information. So here are the characters and how they appear based upon the information that you've put in. You generally don't have to worry about these characters over there. If you do see those, chances are you put in the wrong value. Those are some special Asian characters that are supported because this board is made in China. But over here, these are the characters that we're mostly going to be dealing with. And so for most of those, you can think about them in terms of the normal ASCII chart. So you'll normally be displaying 0 through 9, the letters A through Z, either upper or lowercase. You may need some of these special characters, and so you can see where they fit in. But for the most part, this does follow the ASCII chart. So in thinking about how to program the LCD, you have to make ports A and D outputs so that you can control your RS, your RW, and your E bits on port A, and then you can send your data or instructions on port D. And then you will want to start out by clearing the LCD and going to the home position. You're going to want to use 8-bit instructions, and then you can decide what you want the cursor to do, whether you want it to blink, whether you want it to scroll across with you or not. Every time you send an instruction, this is the basic sequence that will need to be executed. You're going to put the instruction into port D, then you're going to clear the RS bit. I suggest making an alias, and we'll talk about how to do that in a little bit. And then you're going to clear the RW bit, so you're going to be writing, not reading, and writing here is going to be a 0. Then you're going to clear E, you'll delay for a short period of time, and then you'll set E. So that will give you a nice rising edge on the E bit to clock in that instruction. Similarly, for data, you're going to put whatever data you need to write out to the panel in port D, and then in this case you're going to set the RS. That indicates it's data, not an instruction, and then the remainder of the way you execute code is exactly the same as with an instruction. So you can display 16 characters per line, so you may need to limit what types of message that you want on there. You can actually hold more than that, but in that case, to display more than that per line, you'll need to scroll the data back and forth. If you're in one-line mode, then your characters are stored in memory location 00 through 4F in the LCD's memory. If you're in two-line mode, 00 through 27 are for the top line, and then 40 through 67 hex are for the second line. And one practical consideration that you'll need to think about in terms of using the LCD is that you cannot use the LCD and the 7-segment displays on your trainer kit at the same time, because both of them make use of the port A and port D, the same bits there. So if you want to use the LCD, then you won't be able to use a 7-segment. If you want to use a 7-segment, you won't be able to use the LCD. So we'll have a separate video that will talk about some code for configuring the LCD.